Hi, kids. Okay. I'm going to talk to you a little bit about just, again, basics. If you want specifics on how to solve problems, watch one of the other videos. But I'm going to talk to you guys about a general overview about how do you go about solving circular motion problems. So, there's all kinds of different problems. It could be, hey, you're spinning a bucket in a vertical circle. You have a car going over a hill. You have a car turning the corner, so like it's going around the corner, friction causing it to move in a circle. You have whatever the problem is. And the whole point that I'm trying to get across to you guys is that it shouldn't be like, okay, in this problem I need to memorize this, and this problem I need to memorize that, and this. No, look, that's not the case. It's just, you know what? You do what you always do. What is the first thing you do? You draw a picture. In this case, you're going to draw a free body diagram. So let's just do an example. I don't know. We'll say, hey, I have a car. There's my beautiful car. I did minor in art after all. Let's make the front wheel a little bit bigger. And my car is going to go over this. And if you see, hopefully you can see this. Hey, look, at the very top of the hill, it's like a circle. Okay, it's going in circular motion. What is your first thing you always do? Well, you draw a free body diagram. So, all right, so here's the car at the top, and then I have some forces acting. So I have the force of gravity acting, and then I have the normal force acting on that car. And again, it's what forces are acting. But then here you have to do this, okay? Because remember, the whole key to Newton's second law, and this is really just Newton's second law, is that the direction of the net force points in the direction of the acceleration. Well, in this case, I'm going in a circle, and we already know you have to accelerate towards the center of a circle. That's why it's called centripetal. The word centripetal, towards the center. So like here, okay, that I'm accelerating towards the center. So it means my net force has to point towards the center. Well, if my net force has to point towards the center, Fg minus Fn equals MAC. Okay, so in this case you would get Fg minus Fn equals MAC, and remember AC is just v squared over r. Okay, linear speed divided by the radius. Okay, and then you go about solving. But my point is, it doesn't matter what the problem, guys. You could have a problem, with like our flying pig where it's on a string, okay, and it's going around a horizontal circle. Okay. Well, if you draw your free body diagram, you have something that looks like this. Well, geez, which way is it? It's accelerating towards the center, right? Well, what's causing that? This force equals mv squared over r. Again, whatever the problem is, you could have, hey, I'm going in, I'm inside a loop rather than going on the top of a loop. All right, so in that case, I have Fg and Fn acting. So then it would be, those are the only two forces, so it would be this plus this equals mv squared over r. But my point is, the point that I'm trying to make to you guys, is that this is really just a Newton's second law thing. The net force has to point towards the center. So again, the centripetal force, it's a special net force that causes something to move in a circle. So the net force has to point towards the center. Draw your picture, do your steps. Easy peasy. Bye, kids.